So for this short video, we're going to talk about the angle between the two planes. Now, the angle between the two planes, I mean, if you think about it, if they are parallel to each other, let's say if you look at it from the side view, right, this is maybe so-called plane 1 and plane 2, right? So if they are parallel to each other, definitely two parallel lines, the angle between them actually is just 0, right? It cannot be there, there's no angle. The equal angle between two lines, one line in each plane, such that they are at right angles to the line of intersection of the two planes. Okay, I'm referring to the diagram below. So, acute angle between the two lines, one line in each plane. So, I mean, you think about it. I mean, one way to see this, right, is really to look at it from a so-called cross section point of view. All right. So, going on to the next portion. Okay, if theta denotes the acute angle between the two intersecting plane, theta can be actually related to the angle alpha between their two normal vectors. Okay, let me show you what this means. Okay, let's say if I have maybe the first side view, let's say if I have the first maybe the plane 1, okay, and I have another plane 2, right? Okay, so together with plane 1, plane 2, I mean definitely there's a normal vector. So for plane 1, let me call the normal vector n1, okay. For plane 2, let me use red color, let me use the normal vector n2, and n1 is normal to plane 1, n2 is normal to plane 2, okay. And let alpha be the angle between their normal vectors. So alpha is actually over here, the angle between their normal vectors. So if you look at the whole so-called the quadrilateral in general, if this is the sum of all the angles in the quadrilateral must add up to 360. All right, so there's 90 here, there's 90 here, and there's alpha here, right? So basically this theta, which is the angle between the two planes, right, is okay, so actually wait, okay, so over here, right, cancel what I said, this actually equals to 180 degree, right, minus alpha, am I right? Right, so it's basically equals to 180 degree minus alpha. Okay, so with that, right, if this is 180 degree minus alpha, then I can also say that in the supplement context, this angle over here is also equals to alpha, right? So if you think about it, here we always want, I mean here I'm actually assuming, I mean the case 1, for the first case here, I actually show to you that if so-called, I mean alpha is acute, like in this case is acute. Okay, you can see that in order for me to find the angle between the two planes, which is over here, is actually just plane 1, plane 2, right? This alpha is actually equals to my theta, right? And alpha basically, what is alpha? Alpha is the angle between the two normal vectors. And this is equals to alpha. It's equals to the angle between the two normal vectors. So the angle between the two normal vectors is the same as the angle between the two planes in this context. Okay, so I mean you can see basically, right, theta is equals to alpha. Okay, so if I want to find the angle between the two planes, this is the same as me finding the angle between the two normal vectors. So cosine theta, right, is basically equals to just cosine alpha, and cosine alpha is the angle between the two normal vectors. Alright, and definitely because here in the case alpha is acute lah, so you can see that this one definitely because alpha is acute, cosine alpha is positive. Alright, this is for case 1. Okay, this is for case 1, which shows this. Alright, let's talk about maybe case 2. Okay, so if for example maybe alpha, maybe in this case maybe the alpha could be obtuse. Okay, for example, maybe I draw another plane. This could be the first plane. The second plane could look something like that. Maybe the second plane could look something like that. Okay, I mean I'm just usually following the notes, but you can see that okay, this is the normal vector of a plane 2. This is a normal vector of plane 1. Okay, and the angle between the two normal vectors is over here, which is alpha. Okay, let's say alpha again is the angle between two vectors, then definitely this will also be alpha, and following the same storyline, right, this over here will be 180 degree minus alpha, because again some angles in the quadrilateral equals to 360 minus 90 minus 90 minus alpha. You are left with 180 minus alpha. And of course, okay, here we are taking remember we are taking the acute angle between the two planes. So probably the one we are using is this. This is already the angle that we are looking at. Okay. So in this case, right, this is equals to our theta. Right? This is the angle that we are finding, the theta between. We are actually looking at this angle, the angle between the two planes. This is what we're looking for. Okay. So in this case, right, theta actually is equals to 180 degree minus alpha. All right. So theta is equals to 180 minus alpha. And how is this related to cosine alpha? Okay, basically, right, cosine of 180 minus alpha. Okay, because cosine of theta will basically be the same as cosine of 180 degree minus alpha, right? How is this related? So remember, if you go back to our sec 3 A math, right, this is basically just the negative of cosine alpha, right? So again, you can see that I relate this back to the angle between the two normal vectors. So what is cosine alpha? Cosine alpha is nothing but again the angle between the two normal vectors, which is n1 dot n2 over the magnitude of n1 over the magnitude of n2. Alright, sorry, let me just write this properly. Okay. And so I mean this is, in this case it actually is negative. So in order to get the correct answer, the acute angle, we have to take again the magnitude, the modulus of it. So which brings us to the formal result. Okay, the formal result is like that. Okay, that the angle between two planes, right? Okay, we always find the acute angle. The angle between the two planes always find the acute angle. This angle, cosine theta, will be defined as the modulus, okay, of n1 n2 over the magnitude of m1 on n2. Remember that theta is the acute angle between so-called the two planes. Maybe I just call it plane 1, where r dot n is equals to d1, and plane 2, where r dot n is equals to d2, n1 and n2. Okay.